Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Segac cageS by cageS. And if you look at it, it basically is a palindrome. It reads the same one way as it does the other way. So Segac is basically cageS backwards. And soon you'll see why we're using this distinction. Let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have killer cages indicated by dotted lines, cannot have repeated digits, and the digits in the cage sum to the total if shown in the top left corner. So for example, this does not have a sum here, and it's the only cage which doesn't, so these cannot have repeats, that's all we know. These can't have repeats and must sum up to 18. These can't have repeats and sum up to 9. These cannot have repeats and sum up to 15. So as an example, say we had a 4 and a 5 here. Sorry, if there's a 4 here, this has to be 5, because these two digits must add up to 9, which is in the top left corner of the cage. And that's how killer cages work. And all killer cages are either Renban cages or Nabner cages, which is why we have the palindrome word. It's Segac cages. Renban and Nabner lines are essentially the one is read one way as the opposite is read the other way, right? So Renban is Nabner backwards. So if you put them both together, they would form also a palindrome. And the reason why is Renban and Nabners are essentially considered kind of the opposites of each other. A Renban line, so let's continue with what the rules are. Cages with the same total form a pair of... Okay, well, that's interesting. Okay. Cages with the same total form a pair of cages, one of which is a Renban cage and the other is a Nabner cage. So these cages which have the same total must be, one is a Nabner cage and one is a Renban cage. So if this were 4 and 5 here, that's forming a Renban, where in a Renban cage, all the digits form a set of consecutive digits, which 4 and 5 do. And in a Nabner cage, no two digits can be consecutive. So that's why they are considered opposites of each other, right? Renban, you have to have a set of consecutive digits, whereas in Nabner, you cannot have any consecutive digits in the set of digits, adding up to that set. So if this is if this were the Renban line, which works because it's 4 and 5, which forms a set of consecutive digits, then these must not be Renban. And they have to be essentially some form of Nabner line where no two digits can be consecutive. So you could have, say, 3 and 6 here, or 2 and 7, 8 and 1. Those all work. And that's for every cage sum. Every cage is that sum to the same total. So one of these is a Nabner cage, and one of these is going to be a Renban cage. I hope that was kind of clear about how this was. The solver needs to determine for each cage whether it is a Renban cage or a Nabner cage. But we have two sets of digits here adding up to 18. We have two sets of digits here adding up to 22. We have two sets of digits here adding up to 15, and two sets of digits here adding up to 9. Anyways, those are all the things for the Segac cages. We also have digits in cells joined by an X sum to 10, digits in cells joined by a V sum to 5, digits in cells joined by a white dot are consecutive, and digits joined by a black dot are in a 2-to-1 ratio. And not all x's, v's, or dots are necessarily given. So, for example, if this were, say, a 3, this would have to be a 2 here because there's a v between them. And this would have to be, and they must add up to 5. And this would have to be 7 because there's an x between these two cells, and therefore they must add up to 10. If, say, we had a 6 here, this would have to be 5 or 7 to be consecutive with the 6 because these digits are consecutive because there's a white dot between them. And say we had a 4 here, this would have to be 2 or 8 to be in a 1-to-2 ratio with each other because there's a black dot between those. And these are normal black crop key dots and white crop key dots, also normal XVs. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay. Where should we start? We know these digits must add up to 5, so they have to be 1 through 4. So we're going to mark them all as blue to be low, which means they add up to 10 with a high digit, so this is high here. Which means since this is a high digit, it's in a 1-to-2 ratio with another digit, that means it's 6 or 8 here to be in a 1-to-2 ratio with another digit, right? Because 5, 7, and 9 can never be in a 1-to-2 ratio with another digit, because if you have 5, 7, or 9, you get 2.5, 3.5, 4.5. If you double 5, 7, or 9, you get 10, 14, or 18, none of which are digits. So since we know this is a high digit, it's 6 or 8, which means it must add up to 10 with 2 or 4, which adds up to 5 with 1 or 3 here. 6 or 8 is in a 1-to-2 ratio with 3 or 4 here. That means I think we are guaranteed one of these has to be a 3. If this were 8, this is 4 and 2, which forces that to be 3. If this is 6, this is guaranteed to be 3. So either way, one of these two is a 3. Okay. These are in a 1-to-2 ratio, but that doesn't help us much. So we have a guaranteed 2 or 4 here. Interesting. We know 5 cannot be here. If this is 5, that would mean this digit and one of these digits must add up to 10, but we know this digit and that digit adds up to 10. So this can never ever have another digit adding up to 10 with it. So 5 is guaranteed to not be one of these cells, which means 5 in that box has to be one of these 5 cells. We're not sure which. These are low digits, so this must be high here. These are both adding up to 10. And this is in a 1-to-2 ratio with another digit, but we don't have anything really there. So this is 1 through 4. This must be either 1 or 2. 1 could be in a 1-to-2 ratio with 2. 2 could be with 1 or 4. 3 could be with 6. And 4 could be with 2 or 8. So those are the possibilities there. These digits are consecutive. That's interesting. So for the Nabner lines, for the Nabner cages, I should say. Actually, let's do the Renbang cages. For 9, it's 4 and 5. For 15, it has to be 4, 5, 6. to add up to 15. To be 3 consecutive digits, adding up to 15. For 22, it's 4, 5, 6, 7. Well, we know this, again, this cannot be 4, 5, and 6 because they must add up to, they have to be consecutive. So this has to be the Nabner cage here for 15, which means this is the Renban cage for 15, which means it's 4, 5, and 6. So this is 4. That must be then 1 here. This has to be 5 and 6. 5 cannot be next to an X because 5 only adds up to 10 with itself, which means in each row or each column, it would be in. For an X, it can never be next to an X, right? Because 5 and 5 would necessarily have to be in the same row, and we can't have repeats in rows. So this is 5, that's 6, which makes this adding up to 10 with 4 and 6 there. 4 has to be in a 1 to 2 ratio with 2 or 8. So this is 2 or 8, this is 2 or 8. This then, well, it's still, okay, cannot be 2 and 8. Because if this is 2 and 8, that is going to eliminate all possibilities for that cell there. So this must be 4 and 6 adding up to 10, which makes this 3, this 1, to be in 1 to 2 ratio and adding up to 5 here. But this cannot have a 5 here again. Well, how does it add up to 15? That means the 2 remaining digits must add up to 11. You cannot have 5 and 6 because that would be consecutive. You can't have a 3 there, so this must be 2 and 9 to add up to 15 as a Nabner. Okay, 5 can't be any of these because of 5 in the row. Okay, so we have 2 and 9 here. 2 and 9 is adding up to 10 with 1 and 8. Okay. So these add up to 10, and they do not have a 1, they do not have a 4. So this is 2, 8, or 3, 7 here. This is consecutive with this digit, so this must be, can be 1 through 4 or 6 through 9, but it cannot be 2 or 9 because of the 2, 9 pair in the column. So therefore, that's adding up to 10 with this digit. Which could be 2, 3, 4, 6, 7, or 9. These add up to 9, so it's either 1, 8, 2, 7, or 4, 5, because of without the 3 or the 6. These add up to 10 here, without 1 or 3, so this is either 2, 8, or 4, 6. This cannot be 4 here, which means that can't be 6 there. This digit is consecutive with that digit, but if this were 2, it would be only consecutive with 1 or 3, which is eliminated because of 1 or 3 in the row. So this cannot be 2, which means this can't be 8. 4 would have to have 5 there. 8 would have to have 7 or 9 there to be consecutive with it. So that works there. This must be a Renban or a Nabner cage. So this has to be 1, 2, or 3, which makes this 2, 3, or 4 there. 2, 3, or 4 adds up to 10 with 6, 7, or 8. This cannot have 1. It cannot have 6 here, so this is 2, 3, 7, 8 to add up to 10. 4 is here, 4 is here. Okay. As a Nabner line, sorry, as a Nabner cage, that means, well, we know we have 2 digits adding up to 10 in both of the 18 cages. As a Nabner cage, it's 3 through 6 to add up to 18. So you would have to have 4 and 6 be here. Sorry, as a Renban cage, it would be 3 through 6. As a Nabner cage, we have a guaranteed 10. So what would the other two digits? The other two digits would have to add up to 18 minus 10, which is 8. Let's think about this in particular. If we had 4 and 6 here, 4 is consecutive with 3 and 5, and 6 is consecutive with 5 and 7. But to add up to 8, you would guarantee have to have 1 and 7 or 3 and 5 to add up to 8. And therefore, it could not be a Nabner. So if this is 4-6, it cannot be a Nabner cage. What about 2-8? Can 2-8 have that? That would eliminate 2 and 6. You can't have 1-7 or 3-5. So that can't work as a Nabner cage either. So this has to be the Renban cage. Which means this is 6-4, which is consecutive with 5 here. And this must be 3 and 5 here. And this cannot be 5 because of 5 in the column. So this is 3 and that's 5. Which eliminates 3-7 as a possibility to add up to 10 in the rest of the column. So this is 2-8 as a pair. Because it couldn't be 1-9 because of 1 in the box. Can't be 4-6 or 3-7 because of 4, 6, and 3 in the column. That means the remaining digits in column 7 are 1, 7, 9. Okay. 1 can't be here because of 1 in the box. So we have 7 or 9 here. This is 4 and 5 here, so this cannot be 4 and 5 as a Renban cage here. So this is the Nabner cage. Cannot be 4-5, cannot be 3-6. It's 1-8 or 2-7, which means the other 9 cage must be the Renban cage, and this is 4-5. Oops. This is 4-5 here, which eliminates 4-5 in the rest of the column. Where is 5 in this left central box? It can only be here now. So this is 5. 5 cannot be here in the central box, cannot be here. It's one of these two. So 5 is in this cage. To be a Renban line, this is guaranteed to have a low, so it would have to be 1, 2, 3, 4, 5 to form a valid Renban. But we can't have a 4 in this box because a 4 already in the box. So therefore, this cannot be a Renban cage. It must be a Nabner cage. And the only Nabner set of 5 unique digits has to be 1, 3, 5, 7, 9 in normal Sudoku. So this can't be 2. It's 1 or 3, which forces this to be 2 or 4. 2 or 4 must be with 6 and 8 to add up to 10. These are all odd digits, which eliminates all odd digits in the rest of the box. This can't be odd. It's 8, which makes that 2, which makes that 9. 8 eliminates 8 in the rest of the box, so that's 2, and that leaves a 6 here to be the all even digits here. Therefore, this can't be 6 here, this can't be 4 here, because of 6 in the column, and that being 4. This has to be a Nabner. And we've already shown 2-8 doesn't work for a Nabner. 4-6 doesn't work as a Nabner. So this cannot be 2 or 4 here, and this can't be 6 or 8 here. It's 1-9 or it's 3-7. But if we had 3-7 here, how do you add up to 18 with those two digits without repeats? 3 and 7 eliminate 1, 7, and 3, 5, adding up to 8. So that would leave you 2, 6, but 2 and 3 would be consecutive. So this cannot be 3, 7. It's guaranteed to be 1 and 9, which requires 3 and 5 together with it to add up to 18. Because 1 and 7 is eliminated by the 1 in the cage. 2 and 6 is eliminated because that's consecutive with 1. So this must be 3, 5 as a pair. This 3, 4, 5 pair in this lower left-hand box eliminates 4, 5 in the rest of the box. This can't be 5. That's 3, which makes this 5. These digits must be consecutive, and we don't have 5 and 9 available. And if we try to have 6, 7, 8, that would eliminate all possibilities for that cell here. So this has to be 3 here. It cannot be 2, 3, 4 because that would eliminate all possibilities here. So we have to have guaranteed. This can be 1, 2, and 3. Or this is 4 with 3 and 5. It cannot be 4 with 3 or 5, so this has to be 2, 1, 3. It cannot be 4 with 2 here. It can't be 2, 3, 4 because that would eliminate all possibilities for that cell. So this must be 2 with 1 and 3 here. 5 eliminates 5 here, so where's 5 in the central box? It must be there. 2 eliminates 2 here, so that's 4 and 6. 1, 2, 3 eliminates 1, 2, 3 in the rest of the row. No 2, 3 here. No 7, 8. This is 1, which is consecutive only with 2. So that's 2 and 8 here. 2 eliminates 2 here. So that's 8 and 2. 4 and 6 are here. We have to have 8 somewhere in this box. It cannot be here or here, so it must be here. That leaves a 7 remaining in the rest of that box. So the remaining digits now in row 2 is consecutive with 1 or 3. Which is not going to be consecutive with 7 and 9. So this has to be the Nabner cage, which means this is the Renband cage, right? And also Renband has to be 4, 5, 6, 7 to add up to 22. And this does not contain 4, 5, 6, or 7. Okay, so this is 4, 5, 6, 7, which eliminates... This can't be 4, 5, or 6 because of the 4, 5 pair in the column and the 6 in the column. So this is 7, which eliminates 7 in the rest of the row. This can't be 5 or 6 because of the 5, 6 pair in the box. So this is 4. No 4 here. This can't be 5 because of 5 in the column. So this is 6, which makes this 5. 7 eliminates 7 in the rest of the row. So there's no 7 here. This can't be 2 because this would add up to 9. And 2 would force a 7 to be there. 9 here eliminates 9 here. Remaining digits of the central box are 1, 3, 7, 9. 9 cannot be here. 7 can't be here. Remaining digits of column 6 are 1, 3, and 9. Remaining digits of row 9 cannot be 2, 1, 3 because of the 1, 3 pair in the row, or 8. So that leaves 4, 5, 6, 7, or 9. And this cannot be 4 or 5 because of the 4, 5 pair in the box. The remaining digits in this box are 6, 7, 9. No 7 here because of 7 in the column. No 6 here because of 6 in the column. Remaining digits in these have to be non-consecutive. No 4 or 5 here because of 4 or 5 in the column. Remaining digits of column 4. We have 1, 2, 3, and 7. No 1, 3 here because of 1, 3 in the row. No 3 here because of 3 in the row. Where is 2 in row 6? Can't be here because of 2's in the boxes. These are filled out, so 2 has to be here. Since this is 2, this cannot be 2 and 7 adding up to 9. It must be 1 and 8, which eliminates 1 and 8 in the rest of the box. This can't be 1, it's 9, which means this can't be 9. 9 eliminates 9 here, so it's 7, which means this can't be 7, that's 1, which means this can't be 1. 7 is here, and it's on a Nabner cage, so nothing consecutive with it can be on the cage. So this cannot be 6, this is 9. 7 and 9 add up to 16. 22 minus 16 is 6. And if we add 6 with this 1 and 3, you can't have 6 with 3 because it would be 3 and 3 to add up to 6. So this has to be 1 and 5 here. 1 eliminates 1 here, so it's 3. 5 eliminates 5 here, so it's 4, which makes that 5. No 7 or 9 here. It's 6, which makes that not 6, so it's 9, which makes this not 9. It's 7, which leaves a 6 remaining in the row. 3 eliminates 3 in the column, so this is 7. No 7 here because of 7 in the column, so that's 2, which leaves that as a 1, which means this can't be 1, that's 3. This can't be 1 or 3, it's 9. 4 adds up to 5 with 1, so this is 1, and that leaves that as a 3. And I think the rest is just normal Sudoku. 1 eliminates 1 here, so that's 8 and 1. 2 in row 1 cannot be here because of 2 in the column, so this must be 8 remaining, which makes that 2. We have 8 ones. We know where the last one has to be. It has to be there. We have 8 twos. We know where the last 2 has to be. It has to be there. 3s. We don't have enough information about the 3s. 4, we have 8 4s. We know where the last 4 has to be. It has to be there. We have all 9 5s. We have all 9, no, we have 8 6s. We know where the last 6 has to be. It has to be there. 7s. 7 in column 3. These are filled out. It cannot be here because of 7 in the box, and these are filled out, so 7 has to be there. In row 3 cannot be, well, in this upper right-hand box, it has to be here. So that means in this right central box cannot be here because of 7 in the row, can't be here because of 7 in the column, so 7 has to be there. That gives us 8 7, so we know where the last 7 is. It has to be there. 8s in this right central box cannot be here because of 8 in the column, so we're only left here. In row 6, these are filled out. This can't be 8 because of 8 in the column, so 8 has to be there. We have 8 8s. We know where the last 8 has to be. It has to be there. 9s. In row 5, it's left there. In column 5, it's left there. And we have 8 9s now. We know where the last 9 is. It's there. That means we have 3s. It has to be here and here remaining. 4s, I think no. We have 8 4s, so it has to be there, which leaves, this is also 3. Apologies. I didn't realize we were that limited on the 3s. Anyways, that's how you solve it. Would I consider this very easy? Probably not. There's a lot of extra knowledge you really need to be able to figure these out. It's not hard to figure out, and it's not hard to deduce it, but there's a lot of execution to it. So I don't think I would place this as very easy. I would probably put this at easy level. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.